Hello everyone. Yesterday we looked at trend lines and linear modeling, and today we're going to do more of that, looking at a concrete example. So let's get started. So this is going to be writing the equation of a trend line and making a prediction. So we had this data. The table shows median home prices in Florida. What is the equation of a trend line that models the relationship between time and home prices? Use the equation to predict the median home price in 2020. So we'll just pretend that we are before 2020 and we want to predict the home price in 2020. Or we could be doing this now to see how well the model worked at predicting home prices in 2020, because we can run the model, we can see what it predicted, then we can say, well, what were the actual home prices in 2020, because now that's in the past and we can see how good a job it did. And people do that with models. They'll use older data to predict a date that's actually in the past and see how well the model worked. So we have data from 1940 to the year 2000, every 10 years. So 1940, 1950, 1960, 1970, and so on. And we have median home price for each of those years. And so we're going to find a trend line and the actual equation of that trend line and go from there. So we start by making a scatter plot. Now I want to mention that you see the years on the x-axis start at 0. Okay, and that's because it's more convenient to work with those numbers than work with numbers like 1940, 1950. So we see this note down here, let x equals 0 represent 1940, then count years since then. So we're not working with two sets of huge numbers. So 0 is 1940, 10 corresponds to 1950, and 20 to 1960, and so on. So it would be a good idea to pause the video, do this yourself, and draw this graph, and your points will be a little bit different, but just do it yourself. So I'll put this back up here on the data. You can pause it, and then after you've plotted them, start it back up. Okay, so you've had a chance to do that. So now let's look. Here they are plotted. X-axis being the number of years since 1940, the y-axis being the price of the median home price in Florida. So once we've got that plotted, we can sketch a trend line. Okay, and here's the one in this example, the dotted line. So do that on yours. Carefully, make it a trend line that fits the data the best that you can just by sketching it. So you can pause the video again while you do that. Okay, so sketch the trend line. And this says just draw a line through the data that you think best represents it. Now you're going to choose 2 points on the trend line because we need the slope, right? We're going to use the point slope form to write the equation of this line. So we need the slope, and you've done this some in some of the worksheets. Take 2 points on the line. They don't need to be exact. Everyone's will be a little different. And in the example, we're going to see the points were 13 for 40,000 and 41, 80,000. Now notice these points are on the trend line. They are not actual data points. 13, 40,000, 41, 80,000 are not in this data set, right? Actually, there's no year 13 in the data set because there are only 10, 20, 30, and so on. But you just go to the line, pick a point anywhere. Say, you know, just right here is fine. You could say, yep, I'm going to use that point right there. And then that would be about year 15, right? And about 40, let's see, that's 50,000, about 42,000 at year 15, something like that. Okay? So on the trend line itself, it's not one of the points in the data, but just a point you pick out on the trend line. Okay. So do that with a couple of points. You can pause the video whenever you're working on that. It's better to pick your own. So once you've got those points, find the slope. And again, pause it to calculate it with your own points. But with the points that are in the notes, it's the difference in the y's divided by the difference in the x's, right? And you have some big, funny-looking numbers. But now you can see why we didn't use numbers in the 1900s. Instead, we called 1940 0. At least our x's now are reasonable numbers that aren't so clumsy to work with. Here you can see the points that are used. So the difference in the y's is 80,000 minus 40,000. That's right here, 80,000 minus 40,000. The difference in the x's is 41 minus 13. And that's the denominator. So do the calculation, and there's the slope, 1,429. In this example, yours will be a little bit different. Now that we have the slope, we plug it into the point slope form. And hopefully you remember that. That's y equals y, nope, sorry, not y equals. Y minus y sub 1 equals m times x minus x sub 1. M is the slope we just discovered, that just calculated, the 1429. Okay, the y sub 1, of course, is a y coordinate of either point. So in this case, they used the point 13, 40,000. This is the one that's being used. Okay, so plug the 40,000 in for y sub 1, the 13 plugged in for x sub 1, and there it is. Y minus 40,000 equals 1429, which is the slope, times x minus 13. Okay, using again, this is the point we're using. You could use either one. Okay, so then the next step is to distribute. So do this with your own data, and don't hesitate to stop the video anytime you need to. You distribute 1429 times x and 1429 times negative 13 in this case, and then you get this after you distribute. Then the last step, add the 40,000 to both sides to get y by itself. And now you have a trend line right here in the box. So that can be used to make a prediction. The year 2020 is 80 years from 1940, right? 1940 was year 0. So we want to predict home prices in 2020. So if 1940 is 0, 2020 is 80. So that's x. Plug that in for x. and just calculate y. And so in this example, here it is, put the 80 in for x in this equation. 1429 times x, okay, 1429 times 80, plus the 221,423. Calculate it out. And see, this, our copy is losing it on the edge. But the result of the calculation is that y equals this. Okay, and so the median house price will be 135,743 in the year 2020. According to this model, that's a prediction. Of course, we don't say it's really going to be that. That was just a prediction. In fact, it was probably quite a bit higher than that if the data is even accurate that we were using. Yeah, in 2020, I'd say the median price was quite a bit higher than that. So that's an example that could be used in the real world. Someone may do that. A real estate investor might want to plot that line, make some predictions in order to think about how he's going to plan his investments. So you'll be doing some of these for homework with some data. And that's all for now.